Hi. Hi, everyone. My name's Tom Heath, and welcome to this talk, which is all about locomotion solutions and how to integrate them into your applications. I've worked for Oculus for about 5 years now, and solving locomotion has always been something that's quite close to my heart, something I'm really interested in, mostly because I come from a background in computer games, and one of my things that I did as a maker of computer games was fast-paced action games. So I just made this new creation, and I arrived my first days at Oculus. I was very proud to show my new colleagues this new fast-paced action game in VR, only to watch in dismay as, like 30 seconds later, he turned white and disappeared off to the bathroom. And it was just disappointing, and I was kind of thinking, right, we need to solve something, we need to solve this here. So that's why I'm particularly motivated to work on locomotion solutions. I work as part of the Developer Relations Engineering group within Oculus. So we're a group of engineers that focus on helping developers with Oculus hardware, Oculus software, how to use our SDKs, and also sort of working on good practices within VR. And one of those is comfort, and in particular, locomotion. So this talk is all about how to, what locomotion techniques are available and how to get them very readily and easily into your Unity applications and your Unreal applications and native code. I need that at some point, thank you. So the result of this talk, hopefully at the end of it, you'll have an understanding of how to put these locomotion solutions in place, an understanding of what the solutions and techniques actually are. So I'm going to first of all start by recapping what the issue is, then talk a bit about the background of these techniques that we're talking about. Then I'm going to hand over to Luke, who's going to talk about VR Tunneling Pro, which is a Unity plugin which allows you to put these techniques into your apps. Then Luke will talk about, similarly for Unreal, a plugin there. I will complete the picture with native PC SDK inclusion, including people and developers with their own engines, and then finishing up with a summary and what the future might hold. So, very briefly, when we talk about locomotion, what is this issue that we're actually trying to solve? So, really, it's a mismatch between what you're seeing in VR, so movement within VR, compared to what you're actually experiencing in the real world. So, when we're in VR, often applications will seek to accelerate, to add extra rotations, and these aren't felt in the real world by your ears and your body, but they are seen by your visual system. So it's that mismatch that creates the potential discomfort between what your eyes are seeing and what your ears and your body are feeling. So it's linear accelerations, it's often rotations, particularly horizontal rotations, where you reorientate the player to be pointing towards whatever action is going on in the experience at the time. So I'm going to cover the theory of these. There are a number of them. I've presented several of them at Oculus Connect 4 last year. There's a few extra things to talk about. So I'm going to talk about the background behind them. So first off, a technique that we refer to as tunneling. Now, this you might well have seen in a number of applications already. This is where we respond to any locomotion, any movement that is beyond what you're experiencing in real life. We respond to that by dynamically bringing in the periphery of the view, so that, as you can see in this case, we've done a simple example where we shrink it in and show gray in the periphery. Typically, games will have it going to black, and typically they're a little bit smarter as well, with a nice fade, nice vignette on the edge. And the way this works is it diminishes the perceived motion. So a lot of the motion that you see through your visual system is in your periphery. So at suitable moments, then we'll bring in the periphery, and tuned nicely, that will be sort of non-intrusive, but help to keep players more comforted within the applications. Following on from that, like an extension, is if when we reveal the periphery, instead of revealing a flat color, we reveal a static scene. We refer to that as a cage, and that static scene or cage can be full 3D mesh, as you can see in this example, or it could be something simpler like a skybox or a cube map. And the way this works, in revealing a static environment in your periphery, it's like giving your visual system something that reinforces what your body and your inner ear are already feeling. So it's going to stay sort of one-to-one movement with the real world, so it's only going to respond to actual rotations and positional movements that you do in the real world. And with this reinforcing to your visual system what your body's already feeling, then it attempts to eliminate the mismatch between what your senses are saying and leaves you feeling comfortable. Now, how the brain interprets this is rather than you moving through this VR world, it now interprets it as, well, I feel like I'm stationary, so the VR world is moving under me, basically. So it's the VR world moving, not me. And that's how you eliminate that mismatch and create a comfortable experience for users. Another technique that we advocate is the use of windows. So as you can see from the example, it's kind of like analogous to watching television. So we're all used to watching television, and you see fast-moving imagery, but you're comforted by your own real surroundings and your living room, and so that reinforces your sense that you aren't moving, and so you're happy to enjoy sort of fast-paced action within the window. So we recreate this within virtual reality. We can have one window, we can have a number of them, as you can see in this example. And this is just there to comfort you, as long as you can still see that kind of static environment through the edges there. Now this is like an extension of watching TV in the sense that it's a window into a stereo VR world. So you can maximize comfort even more by making it a monoscopic image, so that that screen image can be projected to be level with the window that you're seeing it in. This lowers immersion slightly, but if that's what's needed to maximize comfort in your app, then that's a good option. So portals, this is kind of like the reverse of windows. So now, instead of you seeing a window into the VR world, you have windows embedded in your VR world that are like portals, windows into this static, comforting environment. So as you can see from the example, you go through the VR world, and plotted within that moving VR world are these portals that show the static grey world in this example. And this is, what I should mention here is that there is this concept of training wheels that we've referred to before, and it's a good example to start talking about that. What I mean by training wheels is, with a lot of these techniques, you don't need to have them there present in your application throughout the whole experience, because that could be a little intrusive. So what we recommend is that you perhaps, as part of a tutorial or part of early levels, you have these techniques in place. And then ultimately, you might be seeking to fade them off as people get acclimatized to your experience, or ultimately remove them completely. And perhaps for users who are not susceptible, then they could opt to switch them off. So in this case, for portals, this might represent a tutorial or a training session with lots of really big portals. And then later on, those portals might get smaller. They might become less widespread until ultimately maybe they disappear completely. So this concept of training wheels can be applied to all of these techniques. So they can all be scaled back and reduced as necessary and ultimately just eliminated completely as needed. So another way of mitigating of stopping this conflict between your visual system and what you're sort of actually feeling is counter-optic flow. And what this does is it seeks to take the sort of opposite of the graphics you're seeing, in this case like a mirror image of the graphics, and flow them the other way. So as you're moving, as you're locomoting through the world, you flow the sort of transparent version the opposite direction. So it kind of is seeking to cancel out that optic flow that is creating that mismatch between your visual system and your inner ear. There are different types of this counter-optic flow. So this is a full screen example where we put a transparent version flowing the other way. You could also introduce this reverse optic flow in the periphery. Perhaps if you have a cage revealed in your periphery as you start to move, you could flow that the other way instead of having it static. So just seeking to cancel out that movement in your optical system. It's very tempting in VR games to kind of supply a static environment for comfort in the foreground, particularly something like a cockpit or a head-up display. And this might seem like a good idea because it's convenient in a lot of applications. Unfortunately, it has a drawback in that if you create a static foreground, then unfortunately your brain is inclined to feel like not only are you still moving through this VR world in a potentially discomforting manner, but the cockpit's moving with you as well, and the two of you are kind of hurtling through this environment. So we need to do a little bit more when it comes to cockpits or foreground static objects. A good example of where it works is in space games, because there you have a static environment in the foreground, which is very comforting, and the background has a less of a reality to it. So, I mean, very few of us have actually been in space. It kind of doesn't feel like reality when we see this the space. So we're kind of inclined to feel like this foreground is going to comfort us, give us a static frame of reference, and so we feel comforted by it. However, what we want to do is extend that into a wider field of games. And so for when sort of more Earth-based things, we can diminish the reality of the moving VR world by reducing its frame rate. So in this example, you can see that we're still rendering the cockpit, the foreground, at the full sort of 90 frames a second on Rift, but now we're diminishing the frame rate of the VR world, so it's running at 30 frames a second or less. And this promotes the reality of the foreground and leaves you feeling very comforted by that foreground. So just a reminder, really, that this training wheels concept, you don't have to have your applications all sort of running along at 30 frames a second, but perhaps just to get the more susceptible users into your experience, then perhaps initially, within a tutorial or the first few levels, you have that lower frame rate, and then you ramp it up until you've got all your users at full frame rate for the VR content as well. And finally, final technique, artificial tilt. This is a sort of fooling the brain kind of solution. So many of you might have played an experience in VR where you've navigated and moved around a VR world by inclining your head in the direction of acceleration and kind of steering yourself through the environment. And that works quite well because it fools the brain into thinking there's a component of gravity in the direction you're accelerating when you incline your head in that way. And so, although it's not quite right, it kind of just enough to fool your brain into thinking that things are acceptable. There's not this unpleasant mismatch going on. And what we do here is we take that a step forward, so we don't even oblige your game to have you tilting your head in the direction you want to go. We simulate that by rotating your field of view. So it's kind of fooling your brain twice, and it's unusual, but it works. It seems to work. And it kind of underlines the fact that this is a new technique where we can't really rule out anything. So interesting techniques like this, they may not seem like they're going to work, but we try them and they have merit. So very much a new field that we're exploring. So you're probably thinking, well, that's a lot of techniques, and that will take a lot to try those out in my applications, and that's perhaps development time you don't have. Well, the good news is that we've wanted to make sure that we take that headache away from you. We want to make it very accessible to you to be able to try these techniques in your apps and ultimately include them in your final apps, any that you think have strong merit for your experience. So at this stage, I'm very pleased to introduce Luke Thompson from Sigtrap Games, who's going to talk about making these accessible.
Thanks, Tom. Hi, as Tom says, I'm Luke Thompson. I'm the co-founder and technical director of Sigtrap. We're a small indie game studio, and we've got a passion for VR. So our debut game, Sub-Level 0, which you should see here, is a 0G, 6 degree of freedom shooter. So when we implemented VR support, comfort was obviously a major sort of focus for us. So in developing this, we did a lot of R&D, both into the sort of the causes of sim sickness and how we could mitigate them, not only in sort of this kind of game, but in general. So that, coupled with the research that Tom has done and various other players in the industry, led us to create a Unity plugin called VR Tunneling Pro. As the name suggests, VRTP is based around the tunneling effect that Tom mentioned earlier. It started out as a very simple Unity image effect, but we eventually put that into VR Toolkit. I'm sure many of you have used that. But Tom's research kind of spurred us to go further and implement new techniques and think about this in a slightly different way. So VRTP is now designed to be not just an easy way of implementing a wide range of techniques in your game or your app, but also as a platform for developing further techniques. So we kind of give you a pipeline where you can sort of hack around in the code and try out new things without having to build an entire new framework underneath it. So this is built to give developers and end users the maximum amount of choice possible, because the techniques that you can use are going to depend heavily on your game, and the techniques that appeal to a particular user are going to be very specialized as well. VRTP supports all major platforms, including Rift, Vive, PSVR, Go, and Oculus Quest. And we're really pleased to announce that with Oculus's support, we're now bringing it to UE4 as well. So VRTP offers a seamless plug-and-play baseline of comfort options while giving everybody the freedom they need to really get the most out of this. So this is perfect for Tom's training wheels analogy. It's very easy using VRTP to try out a whole range of techniques, implement them in your app, implement them in your game, and you can sort of scale them up or down as you need. You can give users the option to opt out completely or tailor things to their own sort of choice. And that's a really good way of really quickly trying these things out and getting them in your final build. So I'm going to show you how to set up and use VRTP in Unity to easily achieve all the effects that Tom has just talked about. And I'm then going to show you our work in progress on Unreal Engine 4. Note that some of the features I'm going to show you for Unity are not publicly available yet. They're very much in development, and I'll let you know when that is the case. So if you go out and grab VRTP now, you might be missing some of these sort of more advanced things. So we were going to do a live demo for you guys, but at the rehearsal, Murphy's Law made some pretty compelling counter-arguments. So we're just going to show you some little video loops and what settings you need to change to kind of achieve these results. So this is just our example scene that comes with VRTP, and this is a great way to explore the features and sort of get a feel for what all the different settings do. I've stripped it down for this demo, so there's various other things that you would see in the package, but this is sort of, we're going to build this up step by step. So with the asset imported, all you really need to do is find your main camera and put the tunneling script on it. There is also a mobile version, and that's what you're going to want to use if you're developing for Go, Daydream, Oculus Quest, and that's sort of a more feature-limited version because it's really focused on high performance. But it's also true that the mobile version can be used on non-mobile platforms really well. If you've only got 0.2 milliseconds left at the end of your own rendering, then that's a really great option as well. So to finish setting this up, having put it on the camera, we need to find the object in the world that is actually doing the locomotion. So in this case, we've got a player thing here, which just has a simple character controller script, and you move around with WASD. And that's really simple, so you drag that into this motion target field. And VRTP is going to calculate all the motion values from this to drive the effects that it offers. So if we want to see just a basic tunneling effect, we don't actually need to do anything at all. This is VRTP's default settings. Note that this is keying off angular velocity. So when we're moving linearly, you're not seeing an effect. But by default, when you're turning around, you'll get the effect kicking in. Notice that when you move the HMD, you don't see anything. This is purely driven by the player object to only detect sort of artificial locomotion and not real-world locomotion. So by default, we detect angular velocity, but you can also turn on linear acceleration and linear velocity, and there's various sort of blendings for these. There's minimum and maximum values for when VRTP kicks in and when it maxes out, and you can tailor those to quite a high degree. So this is with linear velocity switched on and angular velocity switched off, so you see the opposite is true. We're turning around, it doesn't do anything, you move in a straight line, and the effect kicks in. And this is really one of those things that's going to affect different players differently, and also depending on the kind of locomotion you're supporting in your game. So, having these as options is a really powerful tool. So to dial in the values that you need for the minimum, maximum, strength, smoothing, whatever, we have this motion analyzer tool. So you can just turn this on in the inspector, and while you're playing, it will record your sort of how you're currently moving and what the peak values are, so you can really easily dial in the values that you need. So we've also got another mode, sort of for the basic tunneling. This is actually applying a blur effect. You'll notice that we've got a whole list of background modes here. I'll go through those as we go, but just for now, I'll touch on the blur mode. This is a nice replacement for the basic tunneling modes for players who maybe find that this vignette coming in is perhaps a bit intrusive for them. There's lots of, you can sort of really dial in all those settings so that it's not, but some people will still have a problem with that. And the blur mode can sort of take the edge off for players who find that intrusive, but have a moderate sim sickness tolerance. It's worth noting it's much slower than any other VRTP settings, as of course it takes multiple passes, and it's quite a heavy pixel shader. So it's also not available on the mobile version. So now we want to put something static in the periphery instead for the cage effect, and this is really simple with VRTP. The easiest way we can do this is set the background mode to skybox. We can select a cube map. VRTP comes with a few, you can see on that box at the bottom. And then instead of just the vignette, we're now fading in this cube map. I've also tinted it, so we can apply a tint color to kind of further differentiate it from the VR world. And there's even this effect overlay slider, which means instead of relying on the vignette, you can actually just fade in entirely all the way across the screen if you need a constant overlay. So that's a really comforting effect. It's really, really cheap. You know, you're not going to see any performance hit from that, and it's really simple to do. So Skybox mode is the only cage mode that we support on the mobile plugin. However, on non-mobile platforms, you can also render 3D objects in the cage very easily. You essentially have an object that's a child, of your player object. VRTP, once you've dragged it into that cage parent box, will turn it off. You'll stop rendering it in the real world, as it were, in the VR world, and it will only be rendered in the vignette. Now, you can hopefully see, it's a little hard to see, but you can hopefully see that as you move the HMD around, you've got sort of full depth perception here, you've got parallax, and for some players, this is going to give a more powerful grounding effect than just the skybox, which is, of course, rendered at infinity. Now, to put objects in this cage, you're going to have to use some custom unlit shaders that we've written, and this is really to sort of focus on performance. And we've got a lot of options with those, and it sort of has its own fog settings and things like that, so you can still get a feeling of depth from it. Now, next, we'll look at masking, which is a really powerful effect, and also I'll show you how to use this to create the window and portal effects that Tom mentioned. So as you can see in this video, the green arrow here is attached to the player. That's sort of static in real space, as it were. And we've got this masking script on it, which means that it is drawn on top of the vignette instead of underneath. So this is really useful for static things like cockpits, perhaps things that are static relative to the player, like your arm or guns, things that you wouldn't really want to cut out with this vignette, and things that you don't need to cut out from the vignette because they're not actually moving relative to you. They're not contributing to this sort of false sense of motion. So this is really easy to set up. On that arrow object, you see we've just got a tunneling mask object script, and on VRTP itself, we've changed the mask mode to mask. And it's as simple as that. Note that this mask mode is completely independent from the background mode, so all of these effects can be combined in a whole bunch of different ways, and that's one of the really powerful things about this, and is also a really nice way of, even without diving into the code, trying out new techniques. Perhaps a certain combination of settings is providing you with some interesting new approach to solving for locomotion. So as I say, we can also use this to create the window and portal effects that Tom mentioned. So if we switch to window mode, what we're actually doing now is instead of masking out the masked objects from the vignette, we're now actually only drawing the VR world where the masking is. Hopefully that makes sense. So this mesh here, this kind of spherical mesh, which again we include with the package, has the masking script on it. We're essentially drawing that to an off-screen buffer, and we're only drawing the VR world where that buffer is present. So behind that, you can see we're drawing the cage. And again, this is, you can combine this with any other techniques. So this could be a skybox, it could be a 3D cage, whatever you like. We can tint that, all sorts of stuff. So this mesh is sort of attached to the user. It's staying static in real space, and it nicely replicates the window effect that Tom mentioned. And again, as Tom mentioned, the opposite of this is portal mode. So instead of only drawing the VR world where the mask is, we're only drawing the cage where the mask is. Both of these techniques, you can still use the vignette, so we can still sort of force the cage to come in the periphery as you move, or you can just turn that off and ignore it entirely and just use it as you can see here. So you can see as we're moving around, sort of indicated by the green arrow, the cage is staying static, it's being shown through these portals, and as Tom says, this is a really nice way to do the training wheels thing, because you can actually build that into your level design, have bigger portals to begin with, and then gradually go to smaller and maybe no portals. And of course, you can still use, if you want a constant overlay, you can turn up the overlay blend and just have the cage superimposed for an extra bit of comfort. So the remaining techniques are, as I mentioned earlier, they're experimental at the moment, they're work in progress, they're not actually publicly available, but they've got a lot of potential, and we're excited to sort of get those finished and get them into your hands. They mostly deal with sort of motion in some sense. So we are either moving the cage or we're artificially moving the camera to result in these effects. So most of these techniques need you to choose a motion effect target and drag it into this box. So in this case, on the hierarchy there, you can see I've got a child of the player, but it's also a parent of the main camera. So this allows us to manipulate the camera and where it's looking without having to override what the SDK is trying to get the camera to do. And we're also still static relative to the artificial locomotion. Again, hopefully that makes sense. There's a lot of layers here. The first technique, this counter motion, this is essentially replicating the counter-optic flow that Tom mentioned. This doesn't actually require that motion effect target because we're manipulating the cage directly. So a simple way of doing counter-optic flow is as sort of Tom showed, you can essentially duplicate your game world and or duplicate your camera, counter the motion, but you're essentially drawing everything twice. That can get very expensive, it can be a pain to implement. So we offer a few different options for getting this done. The simplest option is if you turn on skybox mode and you turn on cage counter motion, you can see that we are actually rotating the cage in the opposite direction to how the user is rotating. In this case, this is just in the periphery, but again, you can turn up the overlay and have this just across the whole screen to some small degree. Again, you can combine this with anything you like, so you could have masks, you could have 3D cages, whatever. If you are using a 3D cage, we can go one step further. So in this case, you can see I'm combining two effects. I've turned up the overlay slightly, so we're not really depending on the vignette. So this is overlaid constantly, and what we've got here is a 3D cage object, which has some triplanar shaders on it, which again come with the package. And these are being, infinitely scrolled in the opposite direction to how you are moving linearly. So we're rotating the cage opposite to your rotation in the world, and we're moving the triplanar shader opposite to how you're moving through the world. So this can be a really powerful effect. And again, these always depend on the kind of motion you're implementing in your game, but this can be quite a powerful one if you tailor the cage to the kind of motion you're doing. So this is, there's a couple of modes here. This is the shader mode. The real mode is where we do actually, or will, support the original technique where we actually physically move the cage around. And then you've got these distance reset and time reset. So every time you hit a certain threshold, it'll reset that mesh to 0 rather than you sort of clipping through things and running out of bounds. You'll note that on both of these you have strength, so you've got a rotation strength, you've got a per-axis rotation strength, you've got a velocity strength, and a per-axis velocity strength as well, so you can really tailor this, and users can play with that on the fly. So next we'll take a look at some cockpit-based techniques. If your game includes a cockpit already, you can very simply put the masking script on it, use the mask mode, and exclude it from the vignette, and you're sort of good to go. But a lot of games don't suit a cockpit, or you've not had time to implement one or whatever. Well, with VRTP you can actually fake it. So one of the remaining background modes, and again this is not yet in the plugin, is this cage-only mode. So instead of drawing a color behind the cage or a skybox, we just overlay it on the world as an alpha overlay. So you essentially get this kind of fake geometry either coming in from the periphery, or again, if you whack the overlay blend up to 1, it will just be there, and you've instantly got a cockpit overlaid. You can see I've done a very attractive grid material on this. I'm not an artist, I'm sure you can tell. So this is kind of a really useful effect if you want to have static geometry that is essentially optional for the user. Even if it doesn't really make that much sense in your game, you can give users the option to have that just for comfort. Now this is where it kind of gets interesting. In either of these cases, whether you've got a real cockpit or a fake one, you can now start dividing the frame rate of the VR world. So we've got this frame rate division thing. And what this means in this case is we're only updating the position of the motion effect target every 20th frame. This is super extreme. You wouldn't want to do it like this. A more realistic example is if you put it to 3, then you've essentially got your HMD and the cockpit rendering at 90 Hertz, and you've got the outside world rendering at 30. And the effect is actually surprisingly comfortable, both in terms of not being jarring and helping you with motion sickness. You kind of get this impression that you're looking at a video game, which of course you are, but you kind of get this idea that you're used to games running at 30 FPS, in the bad old days. But you kind of get this feeling that there's a separate world outside there, and you can move your head around, you can tilt and rotate and all the rest of it, and you can see on here that the motion of the cockpit, sort of within the cockpit, is really smooth. You'll also notice that I've put a few, again, crappy particle effects in here, and what you can see is that because we're only forcing the motion, animations and particle effects and things that are happening in the world are actually still being rendered at the full frame rate. You don't lose anything there. We're only forcing the motion. A nice side effect of this is you can whack this all the way up, and suddenly you've implemented sort of a series of short blinks rather than smooth locomotion or even stepped rotation. You can also choose to not affect the translation or not affect the rotation or have them both on. So as the last technique, I'd like to look quickly at artificial tilt. This is a fairly simple one to set up. Again, it just sort of changes what we're doing with the motion effect target, and you can see as we're moving around here with the cockpit for extra effect, we're tilting the entire cockpit. Like I say, really easy to set up. You've kind of got a strength value there. You can put in a maximum tilt angle if you would like. If you don't, it will just be unclamped, and you can smooth it out, which is not physically realistic, but can be useful if you have any discontinuities in your locomotion. So the last thing I want to talk about here is this concept of presets. So this isn't a technique as such, but this is really a really powerful way of giving both developers and end users the choice they need. So VRTP has a rich API. You can go in and change any setting you like from code at any time. So you can build up options menus, with infinite granularity, and you go for it. But presets are a really nice way that you can sort of build something in the editor and switch between all these settings with one line of code. So you can fine-tune these settings, and you can even make them partial settings. So this checkbox on the right, if that's not ticked, that setting will not be overridden when you apply the preset. So you can even make partial presets. You can make effect presets, background presets, masking presets. They all work independently, and users can choose between all these different settings independently. And we think that's a really powerful feature, and putting this in the hands of users is, again, just really, really important to get the best experience here. So I'm going to quickly go over our work in progress with the UE4 version of this. Just got some videos here. So the core concepts behind all of this is the same, but we want to make sure that this plugin thinks in an Unreal way rather than a Unity way. So in this case, we've got a blueprint character, just a first-person controller. We're dropping the VRTP component on there. It's going to find the camera component underneath and apply an image effect. So as we start moving around, you can see we've got pretty much exactly the same effect. So the effects should be the same, but the workflow is going to be tailored for Unreal. Like I say, a lot of the basic settings are the same. So here we're selecting a cube map to be the cage, and when it eventually starts playing, you'll see that we have the same kind of effect where the vignette kicks in, but instead of just a black space, we have this nice cube map. So again, it's pretty much analogous. There are some differences. So in the case of masking, for instance, as much as we're going through, we're dropping on the masking component on our static mesh actors here. When you actually go to VRTP's settings itself, we're using the stencil buffer. So we give you an option to set what channel of the stencil buffer you're using. So if you're using stencil buffers for anything else in your rendering pipeline, VRTP gets out of the way. You don't need to compromise the look of your game or the tech behind your game to get that done. So if we play here, you can see that as we start moving around, these cubes are masked out. We've got that nice cage effect, again, when we start doing it. And they're nicely masked out, and that works really well. So, one of the most important things about these things is that we want everybody to be able to use them. If this is just something that 1 in 100 games uses, the power of having a consistent baseline of comfort options is diminished. So we're really pleased to announce that with Oculus's support, we're open sourcing it. This will be open source for Unity, for Unreal Engine. It's available today free on the Unity Asset Store as of this morning. And when we get the Unreal Engine 4 version done, which will be a few months, that will be available on the marketplace and on our GitHub, as will the Unity plugin in about a week. So we're really pleased to get this to as many people as we can, because the more developers we have using this, the more end users we can get this in front of, the faster we can develop these techniques and really see what works, what doesn't, how we can tweak things and go forwards with new techniques as well. This is really critical to kind of solving this issue and allowing game designers to put whatever design they like and not be limited so much by the comfort of their audience, as long as we have these baseline options that everyone understands. So we are looking forward to see what you guys do with this. We would love to hear feedback. We want pull requests. We want everything. We want to get the community really involved in this, and that's going to be a really powerful thing for us. So, thanks for listening. I'm going to hand back to Tom, who's going to talk about integrating these in native apps.
Great, thanks, Luke. Thank you. Great, thanks very much, Luke. So as you can see, it's extremely usable plugins for Unity and Unreal, which represents a huge amount of our developer community and what you're developing in. And it's also very free, which is great, and the open sourcing is just brilliant. So now I'm going to talk about the final piece in the puzzle, the native SDK, C++ users, developers who have their own engines. So what we've done here is we've created a series of working examples, so very compact sample code that kind of shows you all of these techniques and shows you a number of variations as well. So what you can see here is the actual sample code that we provide. This is it compiled and running. And you can toggle through by pressing the space bar. You can toggle through, I think it's 42 at the moment, different techniques, variations on those techniques. And importantly, each of them has very minimal sample code. So you can see how we've done it, you can see how we varied it, and you can either lift that code straight out into your code, you could look at the pertinent formulae and take those out, or just see how we've done it and integrate it into your own engine. So these are available. You can download them from our website, the Oculus website, the developer section. So if you download the PC SDK, within that, there are various samples that you're probably familiar with, the Oculus Room Tiny samples. Within that, if you open up a Visual Studio project called Samples Experimental, then this Locomotion project is within that. And you can see all the source code, you can compile it and run it, and really very much see what we've done and extend it if you need to. It's all the source code is there for you. So finally, just a few words about what the future holds and a little summary of what we've heard so far. One thing I will say, it's very much a collaboration, this solving Locomotion. It's a collaboration between Oculus and the whole developer community, really. And I think what are working with Sigtrap Games, and Luke has been a really good example of that, where Oculus have been able to do some research, and then Sigtrap independently have built a plugin, and then they can use with our support, they can add in these extra techniques, they can make it available for Unreal. So we're very much collaborating with the developer community, and we hope to do as much of that as we can. We chose open source because we think that we want to equip developers to be able to research this further. We don't think we've got there yet. We've made some good strides. And so having it open source means that you can look at the code, you can extend it as you wish, you can try new things, and of course do feedback the results to us, because we're really interested. As part of developer relations engineering, part of our job is to work with developers, and particularly to find new solutions and perhaps iterate with developers and use our ideas, work with them, take their ideas, and kind of iterate to good solutions within VR. So lots of exciting things going on. Also, we're not stopping here, of course. Within Oculus, we're researching deeper techniques. We have scientists in the field that are helping us measure what makes this discomfort in some, help us to mitigate it, and ultimately eliminate it so that we can get as many applications just doing whatever they wish comfortably for everybody within VR. So we'll keep you posted on how that goes. So in a minute or two, we're going to open microphones. Luke and I are happy to take questions. There are 2 microphones, one on the left, one on the right. So if you have a question, just step up and we'll answer that for you. So just to recap then, it's all free, all open sourced. In terms of when it's going to be there, as Luke said, VR Tunneling Pro, which is the Unity plugin for these techniques, is, as of this moment, free on the Unity Asset Store. And the source code of that will be available on the Sigtrap GitHub in a week's time. When it's ready in a couple of months, the Unreal plugins will be available on UE4 Marketplace, and again available on GitHub. And currently, as of this moment, the native samples are available to download from the Oculus website as part of our PC SDK. And of course, those have full source code with them. These, as Luke said, these plugins are available for all of the manufacturer's hardware, not just Oculus. They cover the range of Oculus products. It's 3 degrees of freedom, 6 degrees of freedom, the new Oculus Quest, which is very exciting, but also for the other manufacturers as well, so Vive and PSVR. So we're very interested in moving the whole VR community and the whole ecosystem forward. So that's why it was important to us to have this available for all VR. So with that, let's go ahead with questions.